I think we're going to make good progress, probably be done today. So we've talked about and or, and not. So the not operator just reverses the truthiness of it. If age is less than 18, if it said if age greater than equal to 18, then output register to vote, or you could rewrite that as if not age less than 18. Right? That means that you have to be 18 or over to vote. Because if age was less than 17, 18, like if I was 12, then is 12 less than 18?
Yes.
It sure is. But then the not would flip it to a false. So it would say, would not say can register to vote, which is right. A 12-year-old cannot vote. What if I was 20? Is 20 less than 18? Nope. But the not flips it to true, and so that it says it can register to vote. Now not kind of warps the mind a little bit, so I try to avoid it. I would just write this if age greater than equal to 18. That'd be easier for my brain to understand, but the computer doesn't care. It'll, it handles it just fine. It's called a unary operator because it only takes one, thank you for the mistake, Mr. PowerPoint, operand, right? This is the operand for that operator. It could just be a single variable. Like if we'd stored true into the variable A, then it would turn it over and be a false. Kind of like this. A is equal to true, just a second. So if B is equal to not A, then at this point, B is equal to false. Yes, sir.
On my homework line,
Yeah.
I got to, I put in about the 100 phone calls, greater than 100.
Okay.
And it told me line 35 module input if calls greater than 100, string object is not callable.
Let's look at that after class. Or why don't I look at it right now, because it may be something that if you've got it loaded up. If you have it loaded up, then I can look for it, everybody. All right, now let's go to line number 35.
Right there.
All right, we don't need to be telling them if calls are greater than 100 like that. That input is used for writing stuff in. The user's going to type in something, right?
Okay.
So instead, we need an if statement. So we'll give an example of that, right? So I want to get their age instead of the number of calls, or their weight. Weight is equal to input parentheses, what is your weight? Question mark. Now I'm not typing this in idle, so I guess if you are, you better start it off with a triple quote and then end it like, I better bring this over in idle, right? So that we can make sure it works. Why do I not have idle ready to go? Is that it? Yep. All right. Looks like we're on lecture L. So, I want to get somebody's weight. Weight is equal to input, parentheses, quote. What is your weight? Question mark.
Isn't this like, didn't we do lecture in last time? That's what I had to.
Are we on lecture N last time? Are we on,
Lecture in was blank on mine.
so are we on O?
Yeah.
All right, I don't know where I came up with that letter. All right, yeah, I didn't put a title for it. I can go back and put a title on it. But let's go to O now. All right, so we're on lecture O. All right, so we're going to ask them for their weight. You know, and I could have done a print message before that, just saying what is your weight, and then just done a normal input. You know, maybe if I kept with doing that, it would have been less confusing, right? So I'm going to break it up like that. And I'm going to get rid of that little thing because we're not going to type there. But I am going to put a little thing here because I want them to know where they're supposed to type. You're supposed to type in the caret. Well, let's see if that works. All right, yeah, I like that. I like having that there. That's all that putting text inside the input statement does, is it displays it on the screen telling them where to type. If you put a whole sentence there, like if weight less than 90, something like that, then it's going to print that, and that's not what we want. Instead, we just want an indicator of what to print. I mean, where to type. Yeah, I'm going to leave it like that. I better convert it to a float, or at least an int. Weight is equal to float weight. And now I'm good to go. Now I can make some decisions. Like, let's say that we've decided if you weigh more than 400 pounds, you need to see the doctor. So if weight greater than 400 colon, print, go see a doctor. Right. That's silly, but you get it, right? We could ask for their age in the same way. Print parentheses, quote, what is your age? Question mark, end question mark. Age is equal to input, parentheses, quote, angle, end quote, end parentheses, and then convert it to a float. Age equals float age. And now we're going to say if your weight is over 400 or your age is greater than 100, yeah, you ought to see a doctor regularly. You get a clean bill of health if your weight is 399 or you're 99 years old. All right, so it wants to know my weight. 500. What is my age? It's 3. All right, go see a doctor. Since it's an and, since it's an or, only one of these cases have to be true. If neither one of them is true, it's not going to tell me to go see a doctor. All right, what is your weight? I weigh 90 pounds, and my age is 98. Now, neither one of those statements are true, so it doesn't print anything. Does that make sense?
Yes.
All right. So on the last homework, I think, or maybe the homework before, homework 9, you're asked to, like, for the number of minutes and the number of calls you made. You just do this kind of stuff. And then you could have some if statements based on that. Making selections within ranges. We've talked about that. If you're checking to see if something is within a range, you use and. Like, let's say I'm really concerned about people who weigh between 90 and 92 pounds. Real important to find out something about that. So if weight is greater than or equal to 90 and weight is less than or equal to 92, then we print congrats. You weigh the magic number. Silly, right? But whatever. We're using and to see if we are within a range. To check to see if you're out of range, you use or. And you use the opposite signs. Instead of less than or equal, you use greater than. And instead of greater than or equal, you use less than. Now we're going to check to see if they're outside of that range. I should have just used W rather than weight. If weight is less than 90, or weight is greater than 92, colon, print, nope, the weight is not in the magic numbers. It's stupid, but whatever. You get the idea. So in this case, we use or to see if we are out of a range. Outside the range 90 to 92. If we were doing temperature, 32 degrees below that is freezing, above 212 is boiling, so we could have put, temperature and made that 32 and 212. And do the same thing here. if T is equal to, our temperature, 75. If T greater than or equal to 32, and T is less than or equal to 212, we're going to print liquid equals yes. No, that's dumb. I don't know where I'm spacing out there. Print liquid, because it's not freezing or boiling. And to check outside of it, what am I going to do? If T, what's the next thing I'm going to do? I'm checking outside the range.
If T is greater than,
I want to make sure it's outside of the range 32 to 212.
212,
Yeah, so I could do that. If T is greater than 212 or T is what?
less
Than 32, right. Then print not liquid. Now the way my brain works, I probably would have said if T less than 32 or T greater than 212. I probably would have put those numbers the same way, but you got the number. I mean, you got the idea exactly. So either way works. So comments in range, use and. Out of range, use or. Now they show us kind of a silly way to see if something is within a range because they're not using and. Remember we talked about you can use and to replace nested ifs? Well, they haven't used and here for some reason, so they're not using nested ifs. If the number of orders is less than a certain value, no, great. If the number of items is less than the other range, no. If it's less than range 3, yeah, so we used and to get that going rather than doing it the way they're doing it. So if you're doing range checks, you just want to make sure you don't have dead or unreachable paths. Don't check for values that can never occur. You have to have some knowledge of what kind of data is going to come up. Now, what is an unreachable path? What if we did this? Now, this is unreachable, so you don't necessarily need to type it. If temperature is less than 100 and temperature is greater than 200. What's wrong with that? What happens if T is 0? Is that statement true? Is 0 less than 100? Yeah. Is 0 greater than 200? No, and it's an and, so both of them would have had to be true. Now, what if T is equal to 1,000? Is 1,000 less than 100?
no,
And so is 1,000 greater than 200?
yes.
Yeah, but again, it's an and. So since that one was false, it can't trigger. So nothing can be both less than 100 and greater than 200. So it's unreachable code. So this is bad. Would produce unreachable code. I guess you could do the same, which is code that this is kind of like a trivial expression. If T is greater than or equal to 0 and T is less than or equal to 1, I mean like that. Everything is either greater than or equal to 0 and, let's change that to an or, sorry. So if T is greater than or equal to 0 or T is less than or equal to 0, it's always going to be true, right? There's no value that this would not work for. So again, it's stupid. It's not unreachable code. It's more of a trivial expression that always evaluates to true. And in this case, I probably meant to put an or there. And I probably meant to put an and there, and it still looks wrong, if that's the case, right? There's still something wrong with it, even if I replace that with an and. But you get the idea. Using multiple and or operators. If I pull up a binary truth table for and, all right. Now, apparently, an upward pointing arrow means and when you're dealing with binary circuits, and a downward pointing arrow means or. So let's just remember this is our and side and this is our or side. 0 something 0 is equal to 0. 0 something 1 is equal to 0. 1 something 0 is equal to 0. If this was math, does this look like multiplication or division? It looks like multiplication, right? 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. And 1 times 1 is 1. So, and is akin to multiplication. And this is akin, this or is akin to addition. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is, what the heck? Well, remember that we only have two states, 0 and non-zero. So, true plus true is equal to true, right? So, if and is equivalent to multiplication and or is equal to addition, that implies something about the precedence. It means that and has higher precedence in an expression than or. Let's take those as notes. Precedence of and or. And has higher precedence than or. I don't remember where not falls into the, I'm sure they'll tell us. So what does that mean? If we write something like this, if A equals, get rid of the parentheses, if A equals 0 and B equals 0 or C equals 0 and D equals 0, and we want to know in what order these are processed, we could pretend that these are multiplications, and multiplications always happen first. So this looks like if A equals 0 and B equals 0 in parentheses, or C equals 0 and D is equal to 0. Now, if we didn't know that, then our eyeballs might get it wrong. We might just think that we go left to right, right? But if this is multiplication, we wouldn't just go left to right. If this is multiplication, if A times B plus C times D, we would cluster them like that. I don't feel like spending a lot of time on that and actually coming up with examples. My word of advice would be to always use parentheses to make absolutely clear, right? I wouldn't rely on the rules of the language and trusting that the programmer who's looking at the code understands the rules of the language. I'd just make it flat out real clear. What if I have the rules wrong? Well, then if I use parentheses, it would behave the way I want it. So what if we add this? If A equals 0 or B equals 0 and C is equal to 0. What gets done first, the and or the or? And. So how would this look? When we did it, we would put the parentheses around that in our head. That would get done first. Then we could do the or. So mixing and or makes the logic more complicated. You can avoid mixing them by nesting your if statements, or at least by using the parentheses to make real clear how you want the logic to work. And what do I mean by nesting? Well, this one could have been rewritten like this. I don't want to nest it. How tedious. If A is equal to 0 and B is equal to 0. Nah, I don't feel like nesting it. I wouldn't recommend you do it. I'd recommend that you treat the parentheses correctly, but the book shows how it could be done. And lastly, the case structure. Our language doesn't support the case structure, so it's not going to be on our exam. I'm not going to give you any assignments. But here's how it looks. That's nasty. Why don't we give a code example instead? Now, this is not Python code, so I'm going to leave it inside of the triple quotes, right? So say we do this. Year equals 1. Switch based on the year. And if it's case 1, print freshman. Case 2, print sophomore. Case 3, colon, print quote junior. In case 4, colon, print senior. You can kind of see what that's doing, right? It's different. I mean, it's the same. It's just a whole bunch of if statements in a row. If the year is 1, print freshman. If year equals 2, print sophomore. If years equal to junior, if 3, print junior. And if years equal to 4, print senior. And what if none of those were true? Then you can throw in a default case. Default colon, print, golly, I don't know. Our language doesn't support switch case. So I guess it's kind of like if you're at a railroad, yard, and you have a switch, and the switch can send, the locomotive down one of several different tracks. Probably that's why it's called switch. And then they show a PowerPoint. Not a PowerPoint, a flow chart of a switch going on. If your year is 1, you get $175 tuition. If your year is 2, it's $150. It's kind of nice that your tuition goes down the longer you've been here. Doesn't sound right. If the year is 3, your tuition is 100, and otherwise your tuition is 60, right? And so this is a case. These are cases. I'm not going to make y'all do that because we're not going to write any code or pseudocode or flowcharts that involve cases. But tuck it away in your brain. If you take further programming classes like C, C++, Java, JavaScript, C#, you'll see them. All right, our summary. Decisions involve Boolean values and Boolean expressions, which are either true or false. You can use relational operators to compare values if x is greater than 10. If name is equal to Bob. An AND requires that both sides, both conditions be true. An OR requires that either one side or the other, or both, be true. In an AND, you want to put the thing on the left side that is most likely to occur just for efficiency. Because if that's false, then it doesn't even have to check the other side, and that speeds it up. In an OR, you put the thing that is more likely to be true on this side, like if A or B. If A is more likely to be true, we put it first, because if that's true, it doesn't even need to check the second side, right? Because either one of them can trigger it. So for a range check, you compare the highest and lower. You use AND. Or if you're checking outside the range, You use or. And is higher precedence over or. The case structure is a specialized selection structure. Oh boy, what's going to happen when I open that bottle now? All right, that's the end of chapter 4. I knew we were going to hit the end of it. We haven't had a lot of typing, but yes, sir. Sorry? You want me to copy and paste the summary? Yeah, sure, I can do that. That's cool. I should always do that. It's a good idea. Howsoever, I may not leave them up long enough for you to write them all down. Let's get them in there. I'm going to skip the case structure one.
You're gonna have that with the lecture notes?
Yeah, it's going to be in the lecture notes. And you're never required to put everything in your notes that I put up here. That's why I upload them. Yeah, there we go. So we're good to go now? Yeah, all right. So we're pretty much right on schedule. And we have talked about looping before. So I'm glad of that because now when you see it on the PowerPoint, it's going to be locked in. You're going to get it.
I got a question.
Yes, sir.
So when you put an and or in there, do you have to capitalize?
No, there's no capitalization. If I've typed caps,
I noticed you had.
if I typed caps, right,
In the note,
that's just to make it
precedence
easier to
or,
see. Right.
And then capital and or.
Right. That was just to make them easier to see. I could have put quotes around them for that purpose. That makes sense?
Yes.
And apparently I did that all through my notes, or they did it. This is their fault. This is when I copied and pasted the notes. I blame them. It's not my responsibility. Nobody saw me do it. Here we go. So the advantages of looping. Looping is pretty much all what computers are all about. Your game loops waiting for you to get input. Pac-Man loops getting input for about which way the joystick's going, and it updates the position of your Pac-Man, decides which way the ghosts are going to go, and it redraws the screen, and it repeats that over and over. So we can write one set of operations that operate on multiple sets of data. Less time required for designing and coding. If you find yourself copying and pasting stuff, then think about whether you can make it a loop, or think about whether you can make it a module. So a loop is a structure that repeats actions as long as a condition continues. While x is less than 10, keep adding 1 to x. And it'll keep repeating that until the condition is done. I wouldn't call it a dual alternative structure. To me, this looks like a single alternative structure. If the condition is true, it does something and it repeats it. If the condition is still true, it does it again and it repeats it. As long as x is less than 10, it's going to keep adding 1 to x and repeating. And when it's finally done, it falls down and does something else. So I don't particularly think of it as a dual alternative select structure. So as long as the condition remains true, the statements in a while loop body execute. We could control the number of repetitions with a loop variable, right? You initialize your variable equal to 0. You check to see if it's less than 10. If it is, inside the body of the loop, you add 1 to it. So you initialize it before, and then you test it. And the body of the loop had better alter the loop control variable, or else it's an infinite loop. Like, let's do that. Let's make a simple loop that counts from 0 to 10. So counter, C is for counter, equals 0. This is our initial value. Well, C is our loop control variable. 0 is the initial value. And then we have a condition. While C less than 10, colon, that's our while condition, we do something, whatever the loop body is supposed to do. Print C times C. Whatever. And then we better update it, or else it's not going to exit the loop. Unless we use a break statement somehow. But if you have a counting loop, you're probably not going to use a break statement. C plus equals 1. And that's the update, the loop control variable. Update the LCV. Now if I ran it, it would print out 0, 1, 4, 9, 16. It's going to print all the powers of the numbers from 0 to 9. Why is it not going to print 100? Why is it not going to print 10 times 10? Right, the expression is less than 10. So when it finally equals 10, it's no longer true. Just like an if statement, if 10 is less than 10, well, that's not true. It would no longer go back in there. So you could use a counter to create a definite counter-controlled loop, and that's what we have here. This is a definite loop. It uses a counter. We know how many times it's going to run, right? We're starting C at 0, we're going to go up to 10. An indefinite loop is when you're not quite sure when it's going to end, and so it needs some kind of signal value. Like enter test score or -1 to quit. Let's do that. N equals input, parentheses, quote, do something, question y/n, end parentheses, end quote, end parentheses. And then we're going to have our while condition. While n equals, quote, capital Y, end quote. And then we're going to print, okay, doing something. Then we're going to ask them that again. N equals input, parentheses, quote, do something, question mark, y/n. End quote, end parentheses. And it's going to keep repeating that as long as n is equal to y. Now I'm going to rewrite this a little bit. I'm going to rewrite it so that the sentinel value is absolutely clear. Right now the sentinel value is anything other than y. But I'm going to change that while statement to say while n not equal to, tell you what, let's make what they type in either yes or no. And so if n not equal to no, then keep repeating. There, I just changed all the yeses and nos, all the y and the n's to yeses and nos. So this is an indefinite loop. The following is an indefinite loop that loops until a sentinel condition. Sentinel value. In this case, no is our sentinel value. No is the sentinel that stops the loop. And the sentinel value can be anything that you want to stop the value, right? Enter score or -1 to stop. Enter choice or quit, Q to quit. While data is not at end of file, keep looping. So it's an indefinite loop because we don't really know in advance how long it's going to keep running. I don't know how long the user is going to keep typing yes. They might type no to begin with, or they might be insane and type yes 2,000 times in a row. Let's make sure it works. Nope, it doesn't. Somewhere I have a colon, a straight colon. You probably won't. All right, what is your weight? 200. What is your age? 200. Do something? Yes. Okay, doing something. Do something? Yes. It's going to keep repeating that until I finally type no. So your loop could be, while Pac-Man's lives are greater than 0, and right when he finally dies, we remove 1 from the number of lives, and it's no longer greater than 0, and it's game over. Better put another quarter in. While quarter is less than 1, while before they put any money in, don't do the loop. While quarter is greater than 1, keep playing the game. One of our loops is going to be to implement the classic guessing game. I'm thinking of a number between 1 and 100. And we're going to keep looping as long as their answer is wrong. And if they finally get the answer right, whoop, we can exit the loop, tell them they win. Then we might ask them if they want to play again. So we might have a nested loop, a big loop which dictates whether they want to play again, and a loop inside there, which is have you guessed the right number yet? So definite loop executes a predetermined number of times. A counter-controlled loop or a counted loop is a form of definite loop. It counts as repetitions, 1, 2, 3, 4, 5. You might use a for loop for that purpose. If it's a counter-controlled loop, a for loop is better than a while loop. Here, we counted from 0 to 10 to 9, well, while C was less than 10, and it took 4 lines of code. But we could do the same thing with just 2 lines of code, like this. For C in range, starting at 0 and continuing to run while C is not equal to 10. And then print C times C, print C squared. Right? That's cool. We did the same loop, but it only took 2 lines of code rather than 4. So I'll put that as a comment. A counter loop is probably best done with a for rather than while. Because if all it's doing is updating a counter, then that's a perfectly nice, clean syntax for it. Why is it so much shorter than the other one? I'm going to scroll up for a second. Because we did not have to initialize the loop control variable. And we did not have to update the loop control variable. The for statement handles both of those things. So if we look down here, we don't see initializing C, and we don't see updating C, because the for syntax handles all that for us. And I'm going to put one last comment that this counts, but the fancy word is iterates. This iterates from 0 to 9. Tuesday would be a good day to do the guessing game because we'd have time to draw the flow chart for it as well. And I don't just want to type it in top to bottom. I want us to actually organically develop it. So an indefinite loop is one that runs a different number of times each program executes, right? We don't know how long. Your car's programming, if you are driving a Tesla and it knows how to drive itself, well, that's great and all that, but it's got to stop driving at a certain point. So once you put on the brakes, then that program is going to stop. Well, that's going to be the Sentinel value, right? Your brakes are applied. Something like that. I don't know how Teslas work. So, in a program's mainline logic, you pretty much need 3 steps. You need a starting value for the control variable. You need to test the loop control variable to determine whether the body executes. And you need to alter the loop control variable within the loop. Now, even if you do my favorite weird form of loop, which is a while true loop, let me show you the syntax for a while true loop, just because. C is equal to 0. While true, keep repeating this stuff. Print C times C in parentheses. Add 1 to C. C plus equals 1. And then lastly, we're going to check. If C is greater than 9, colon, hit return break. Now that's a silly way of writing it. I usually do this for Sentinel value-based loops, like ask a user if they want to run and run again. And if they don't want to run again, then break. What does break do? It causes it to exit the loop. What does while true mean? Well, instead of having a mathematical expression, while x is less than 10 or whatever, it just keeps repeating over and over and over until we hit a break statement. Don't do it that way. To do a counter-based loop based on this syntax is insane. Still, we do see those 3 things that the PowerPoint recommended. We see starting it with an initial value. We see doing a comparison. We see an update of the value, right? It's got all the pieces. It's just arranged in a different fashion. The only reason I show it to you is because I am pretty sure I'll use a while true loop later, even though it's not in the book. Some books show it, some books don't. While true just means run infinitely until a break is hit. If we took this code out, then it would run forever, right? Don't do this because it's going to run forever. I'll have to add it back. Yeah. But I'm going to put a comment as to what's going on. A while true loop repeats forever, parentheses, until a break statement. And when I say don't do it this way, I mean don't do it this way for counting loops. I've already told you that for counting loops, the for loop is the best. While loops are second best, and this in a while true loop would be bizarre. That page is important enough. It shows up on your quizzes, I think. It shows up in the exam. We're going to write it down. I think we kind of already did, but we're going to do it again. Mainline loop logic. Initialize a variable, test the variable, and update the variable. And we demonstrated that in our very first while loop. Counter equals 0 was the initialization, while C less than 10 was the testing, and updating is C equals C plus 1, or C plus equals 1. It'd be weird to get through this chapter in one day. So, nested loop facts. Now this is probably a quiz and a test question. Nested loops never overlap. But what does that mean? Well, we're going to just write it down. Tested loops never overlap. Let's see if we can figure out what that means. The inner loop goes through all of its iterations before the outer loop goes through one. Let's make a nested loop. Print parentheses, print some nums, question mark, y backslash n, in quote in parentheses, and let's get our input. Do it equals input, parentheses in parentheses, and while do it not equal to quote in end quote, we're going to do something. Now we're going to have an inner loop. To make it simple, I'm going to use a for loop rather than write it out, because you can write a for loop in 2 lines rather than 4. For x in range 1, 11, parentheses, colon, and this is going to count from 1 up to 10. It stops when it hits 11. And we're going to print x out. Printing, parentheses, end quote, comma, x. And then we better ask them again. We need to ask these same 2 questions. Honestly, it'd be faster to copy and paste them. However, people who are writing by hand can't copy and paste as easily. So, print them again, question mark, y slash n, end quote, in parentheses. And then do it equals input, parentheses, in parentheses. And that's the end of our loop. So the inner loop has to run completely before the outer loop will repeat, right? It can't escape from this for loop to print this message until the for loop is done. All right, print some numbers? Yeah, sure, why not? And it prints them. It prints them all. The for loop iterates from beginning to end before it asks me again. Print them again? Yeah. Print them again? Nah. All right, so we're done. And we saw the way that worked. This loop here had to repeat all the way until, or it had to complete before we could ask if we wanted to do it again, and the outer loop could repeat once. That's what they mean by overlapping. Tested loops, that should have been nested loops, I'm sorry. Nested loops never overlap. The inner loop must complete totally before the outer loop can repeat again. So when we write our guessing game, the outer loop is going to be, do you want to play the game? The inner loop is going to be, while guess is incorrect. When they finally get the correct guess, great, it's going to exit that inner loop, and we'll ask them, do you wish to repeat the game? And if they choose no on that, then we're outside of the outer loop. Mistakes. Failing to initialize the loop control variable. This is a mistake. If name equals quote Joe. Well, that's going to be a syntax error. Why is that? Or while name is equal to Joe, right? It doesn't matter. What's wrong with that code? The syntax is correct, and there's nothing wrong with the while statement itself, but I have forgotten to do something.
But in parentheses.
Doesn't need parentheses. Let's run the program and see what it complains about. Well, besides that unexpected EOF while parsing. What does that mean? What did I do wrong? That means I have some triple quotes somewhere that I shouldn't. Bless you. Oh, it's because I don't have anything in here. print yo. We're going to print yo Joe. All right. All right. It prints name is not defined. Why is it printing that? That's our error message. Name is not defined. If I wanted this code to work, what would I need to do? I know somebody has it and they're just not telling me. Why is it saying name not defined? That's almost a tautology, guys. If name is not defined, why? Because it's not defined. Well, how would I define it?
Name equals input.
Yeah, I'd have to do something like name is equal to input, right? Or at least set it to something, right? If I don't do this, then it can't start. It can't. We don't have this variable defined. So the variable has to be defined before the while loop. The loop control variable has to be defined. Now the nice thing is if it's a for loop, it defines the loop control variable automatically. But for a while loop, it doesn't.
So that's
If you get variable not defined, it means that the variable was used before it was created, before ever being given a value. Most likely it means that you made a typo. Or you forgot what the variable was called, right? You called your list ages, and then later on you called it age, right? Left off the S. Something like that. But it's possible you completely forget. I'm perfectly capable of writing a loop that says this while n is not equal to no without remembering to initialize to create an n variable beforehand. So let's put that as a common error. Failing to initialize a loop control variable before testing it. All right, it's fair game for me to give you a program, a screenshot of a program, and say what's wrong with it. And the problem is that the loop control variable was never initialized, right? Could even give you a screenshot, you know, of the error message. Or I could ask you how to fix it, right? Now, we're not going to really get to this today, but we are making good progress because we have already talked about loops to a fair degree. So another mistake, neglecting to alter the loop control variable. This code demonstrates that problem as well. If I type in Joe, what's it going to do? It's going to print yo, and then what's going to happen? Not nothing. If it was an if statement, it would be nothing, but it's a while statement, which means repeat this code as long as the condition is true. So what's it going to do?
repeated.
It's going to repeat it infinitely because I did not update the loop control variable. This is getting tedious to run because of all these input statements. Right? Woohoo! All right, so we better ask them for another name. Yeah, bless you. Name is equal to input, parentheses, input, right? Give me another. Right, something like that. Common error, failing to update the loop control variable in the body of the loop. This results in infinite loops. Another mistake, using the wrong comparison. You better use the correct comparison. The seriousness depends on the actions performed within the loop. What if we overcharged insurance customers by a month? What if we overbooked a flight on an airline? What if we dispensed extra medications? Well, I don't know. All sounds serious stuff. So, for example, if we were trying to print out all the months of the year and we wrote our for loop wrong, right? For month in range, I want to start at 1. How many months are there? 12. I'm going to put a 12 there. Wait, I'm not putting this in idle. For month in range, 1, 12, colon, print the month. And I wanted to print out 12 months. Obviously, it's supposed to do more than that, right? But at the very least, I wanted to print 1 to 12. I'm going to rewrite this, though, so it uses a while loop because for loops make things too easy. So, month equals 1. And then while month is less than 12, colon, print the month. And what's it going to print out? It's going to start at 1, and when is it going to stop? Yeah, except I made a mistake. It's going to be an infinite loop because I never added 1. But that loop runs 1 to 11. And we meant it to go 1 to 12. So our comparison was wrong. It didn't because our comparison was wrong. Should have been while month is less than or equal to 12. Or you could have done it while month is less than 13. Either one of those two would fix it. So that's another common error. Common error. The comparison has a problem. They say not valid. It's like it's valid, but there is a mistake in it. It's a logic error. I guess they don't say valid, they say using the wrong comparison. I'm just going to say the comparison is wrong. And mistake, including statements inside the loop that belong outside the loop. And we see this one a lot. Like this one. Total equals 0. While x is less, well, I don't have the x defined yet. X equals 0. While x is less than or equal to 10, colon, total plus equals x, x plus equals 1. And then lastly, I want to calculate the average. Or at least I want to print the total. Print, quote, total equals, end quote, comma, total. Looks right to my eyes. It's not going to run exactly how I want. All right, I've got a serious mistake that I didn't mean to have in the code.
The 1 and x equals 1.
Oh, look at that. What's wrong with that? I just typed it wrong. What should it be? plus equals. All right. And it runs, but it prints out a whole bunch of totals. What if I only wanted it to print one total? What would I do to fix it?
You said at the beginning x equals 0 and you got x equals 1.
Either way, we're calculating a sum. Its behavior would be not much different if we did it that way, because if you add 0 to something, it doesn't change its behavior, doesn't change the value. All right, so anyways, I didn't want it to print a whole bunch of totals. I only wanted one answer. What would I need to do to make it only print out the total one time rather than 10 or 11 or how many times it's printing it?
Take out the times 10. I mean, no. Plus, take out x plus.
Well, if we took this out, it's just going to add 1 and it's going to run infinitely. Even more tedious. Alrighty. All right. We had to have that because that's what was increasing x each time. But I still don't want it to print the total every time. Why is it printing the total every time?
But you have it twice.
No, I only have one print total statement.
The print is in the while statement and you want it outside of the statement.
Exactly. The print is inside the loop. Oops. The print is inside the loop. So it is printing a bunch of times. I wanted it to only print one total, so I should have unindented it. And if I did so, if I went over here, did that, it only prints one total, which is what I want. But to illustrate the mistake, I'm going to do that. So another common error, including things inside the loop, in other words, indented, that should be outside the loop. And have we not already done some loop homework, like counting from one number to another? Does that sound familiar? I think I'm going to skip giving you all a homework assignment over this because we've already done that. We're just discussing it in more detail. How about for loops? Have we used for loops in our homework yet? All right, we'll do that. There's several things to know about for loops. For x in range 10, 20, 2, that is going to count 10, 12, 14, 16, 18. It adds 2 each time. If you leave the first number off, it starts counting at 0. So to count from 0 up, I can leave the first number off. For x in range 10 is going to print from 0 through 9. What if I put a negative number there as the last one? It'll count down. For x in range 20, 10, -1. Somebody guess what the last number is going to print. It's going to start counting at 20, and it's going to subtract 1 from it each time. So it's going to go 20, 19, 80, 18, 17. What's the last number it's going to print?
-0.
Well, it's going to stop before it gets there.
-1.
Why? Because what is the second number? The second number is the limit, right? So if we were going from 0 to 10 plus 1, what would it count? It would go 0 to 9. But instead, we're starting high and we're going low. And it's okay, you're getting it wrong because I said guess. What numbers are going to stop at? 10 is our limit. So where is it going to stop?
-9.
It's not going to go negative. 11 is correct. This is going to count 20 through 11 because it stops when it hits 10. So our homework is going to be pretty easy. It's going to be based on those ideas. Write a loop that counts from 2 to 100 by 2's. I prefer for it to be a for loop. Write a loop that counts from 10 to 20 by 1's. That's too easy. We've already done 10 and 20 and stuff like that. How about from 100 to 110 by 1's? And I write a loop that counts from 109 down to 1 by negative 1's. So really, that might take you only 2 minutes based on what we've done. If it takes longer, that's okay. Learning process. You learn by banging your head on it. All righty. Any questions? Nope. All right, I'm going to stop the recorder. Then check to see if anybody had syntax errors they wish I'd helped with earlier.